All right, let's get into it. Today we're going to talk about a star that just, well, it breaks your brain a little. It's so big, it pushes the boundaries of what we even thought was possible. We're heading about 20,000 light years away to meet Stephenson 2-18.
So you gotta wonder, right? With all the stars out there, trillions upon trillions, what's the absolute biggest one we've ever found? Which one is the undisputed king?
Boom, there's your answer. Its radius is about 2,150 times bigger than our sun. I mean, just let that number sit with you for a second. We're not talking 100 times bigger. We're talking over 2,000 times the radius. It's just staggering. Okay, so how do you even wrap your head around that? Let's try this. Imagine we could just pluck our sun out of the sky and drop Stephenson 2-18 in its place. Well, goodbye Mercury, Venus, Earth, and Mars. Goodbye Jupiter. The surface of this star would stretch all the way out past Saturn's orbit. Our entire neighborhood, everything we know, would just be inside it.
So yeah, it's a cosmic titan for sure. Let's really try to nail down just how massive we're talking about here.
You've probably heard of other giant stars, right? Like Betelgeuse. And yeah, Betelgeuse is a monster, about 900 times the sun's radius. But look at this, Stephenson 2-18 makes even Betelgeuse look tiny. It's not even in the same ballpark. It's a whole different sport. And hey, if the radius is that crazy, the volume is where things get truly ridiculous. You could cram about 10 billion of our suns inside this thing. 10 billion. That's a number that doesn't even feel real, you know? Okay, so it's big, we get it, it's unbelievably big, but what is it? What is this giant red bubble of gas really? Let's dive into the anatomy of this thing. What's wild is that compared to our sun, it's actually pretty cool, temperature-wise. That's what gives it that deep red look. But the real mindbender? It's density. It's almost nothing. It's this enormous object that's so spread out, so puffy, that it's almost more like a giant glowing fog than a solid star. And there's a reason for that. It's what we call a red supergiant. Basically, it's a star at the very end of its life. Think of it like a furnace that's run out of its main fuel, so it starts burning whatever else it can find. The core of the star shrinks and gets insanely hot, and that intense heat just puffs up the outer layers, inflating it like a colossal balloon. There's this fantastic description for it that really gets the point across. It's less a compact sphere of fire and more a tenuous, roiling atmosphere barely bound by its own gravity. I mean, isn't that amazing? It's so big and fluffy that its own gravity can hardly keep it from just drifting away. So ironically, this incredible size isn't a sign of power, it's a sign that it's old and on its way out. This star's story is the classic tale of living fast and dying young. Stars this big have really short, violent lives. It would have started out as this brilliant, hot blue star, just blazing away. But it burns through its hydrogen fuel in only a few million years, which is nothing in cosmic time. Once that main fuel started to sputter, it puffed up into the red supergiant we see now. It's like its last big, glorious gas before the end. Someone called stars like this cosmic spendthrifts, and that just hits the nail on the head. Our sun is careful, it'll sip its fuel for billions of years. These things, they just guzzle it down. They burn incredibly bright, and then they're gone. And yeah, being this big is not a stable way to live. The energy pushing out from its core is so powerful, it's literally blowing itself apart. It's constantly shedding its outer layers into space, creating this huge cocoon of gas and dust all around it. All of this instability, this massive size, it's all leading to one thing, a grand finale, a really, really big explosion. So what happens when this Titan finally goes supernova? Well, here's the timeline. It's going to keep losing mass for maybe the next few tens of thousands of years. Then, one day, the fuel in the core will just run out. Gravity will win, the core will collapse in an instant, and that will trigger a supernova that will light up the galaxy. And after the dust settles, you're left with either a tiny, super dense neutron star, or more likely for something this big, a black hole. Okay, but let's take a step back. How sure are we really about this number? 2,150 times the sun? And this is where the science gets super interesting, because trying to measure something like this is, frankly, a huge challenge. I mean, think about it. First, it's about 20,000 light years away. Pinpointing that exact distance is tough. Second, there's a ton of interstellar dust in the way, blurring our view. And maybe the biggest problem? It doesn't have a solid surface. It's this fuzzy, pulsating edge. So where do you even start measuring? A tiny mistake in any of these can lead to a massively different side estimate.
So yeah, the exact number might change a bit as we get better data, but you know what isn't up for debate? Its ultimate fate. And this, for me, is the coolest part of the whole story. Its death isn't just an ending, it's an incredible act of creation. Because when it goes supernova, it's going to spray all the heavy elements it's been cooking up for millions of years. We're talking carbon, oxygen, iron, all the good stuff, across the galaxy. That material is the raw stuff needed to build new stars, new planets, and eventually the stuff needed for life, for us.
So think about it. This Titan is going to die. But its spectacular death is really a beginning. Which leaves us with a pretty profound final thought. Could the ashes from this one star someday become the building blocks for a world just like our own?